Good morning. I'm on site here at Embedded World 2023, and joining me today is Martin Kellermann, Marketing Business Development Manager at Microchip Technology. We're going to be talking about intelligent edge computing with RISC-V. Martin, could you give us a brief introduction to yourself?
Yeah, good morning as well. Also welcome to the show from my side. My name is Martin Kellermann. I'm with Microchip Technology, working in the FPGA business since probably about 23 years up to now. I've been in that industry a long time, and I've seen quite a lot of applications, industrial, automotive, communication, also quite some high-speed interfaces that I've been working on with our customers, clients at that time. So very nice background I have. I think for that topic, it also matches pretty nicely.
Okay. And can you also introduce the company you work for, Microchip?
Sure. So Microchip is known mainly for its microcontrollers, starting from the 8-bit microcontrollers, 16-bit, 32-bit microcontrollers, MPUs. But we also have a lot of other components like clock components, power supplies, PCI Express switches, and even more than that. And even more than that, that's the business unit that I'm working in, the FPGA business unit, where we are working on typically mid-range devices on the FPGAs and FPGA-based SoCs.
Okay. And now let's move on to RISC-V. Just give us an overview. What is RISC-V?
RISC-V, for me, is kind of the openness to invent. It's based on development that was done about 10 years ago, started in the University of Berkeley. And the essential bit for me, it's an open ISA, instruction set architecture, that defines a certain behavior, and then has also the openness of adding more to that as custom instruction set. And based on that openness, you really have the possibility to innovate, to add something more, and really build what you require for your application.
Okay, well, that leads me into the next question. What are the benefits of RISC-V?
Mm-hmm. So for me, the biggest benefit is really this openness. The openness combined also with the background on how it's set up. So the setup is, it's a non-profit organization that is really taking care of it, where you can contribute, where also people from the industry are putting their thoughts in. But it's not really just one company that owns it and that has the say on what is done and what will not be done. So based on that, you have the assurance that if you invest in RISC-V, if you put your bet onto that architecture, if you also do the development on that, this investment is really well seeded. You don't have the risk of the architecture just being cut off, or the company being sold off to somewhere else, or a decision that might be taken off. We don't know what we are going to do anymore, so we just shut it off again. So RISC-V is really the openness. You have the possibility to build something yourself, which you can own. Also, when you go for processors, where you might do the development of your own processor, like a soft core implemented in FPGA, you don't have any royalties to pay, any license fees. It's just your own. You can get the ISA, you can develop according to that. And with that, you also, again, protect your future for your own innovation.
Okay. Well, where is RISC-V being used?
The very simple answer is nearly everywhere. So if you start off kind of on the low end, there are very low-end microcontrollers based on RISC-V. But it also really goes up to the high end. If you look up, multi-core space computers based on RISC-V. And that's really again, showing the benefit. You can go for a full range of that. Also, if you look at our devices, PolarFire SoC, mid-range class device, quad-core application processor, 64-bit, up in space, down on Earth, full range of applications that it can do there. Going for automotive, going for industrial, going for medical, that's something where you can really put that in. And if I just take medical as one example, it also goes very nicely with another benefit, not just with RISC-V, but here with our architecture, longevity. If you can get the devices for the next 20 years or more, if that is promised to you by the vendor, it's also a lot of money that you can save on paperwork. If you go for medical applications, one of the very big cost factors is certification. So if a device gets obsolete, it's a really huge investment to get the recertification. No obsolescence, no recertification, lower cost for that application.
Okay, well, you talk about cost, and RISC-V with embedded systems and IT applications have a focus on cost, customization, and often low power. So changes are happening at the edge of the network, and I was wondering maybe you could tell us about these changes.
Mm-hmm. So if you look at those edge devices, the one thing that is pretty common in the development is there is more intelligence added to those edge devices. A couple of years ago, it was maybe just a sensor, but now it's an intelligent sensor connected to the network. And yes, those are absolute innovations. Those are a lot of chances that you can do with that. You have the freedom to innovate. It also comes with a burden, comes with a certain risk that you need to take care of. If I'm connected, if I have intelligence, then I also have some power of doing something wrong. Imagine you have a sensor. Let's just go for a very simple one, a smoke detector or an alarm detector. If that is connected to the network and has a processor inside and it's not protected, it's relatively open. So an adversary could get into that sensor and just trigger a false alarm. Doesn't really sound too bad. It's just a false alarm. But what happens if that thing is connected to the network and there are some additional actions taken, like opening up the doors so that people can get out? If this is done at the wrong time, at night when nobody's in the building, somebody could get in and get the material out. So the security is absolutely an essential part of that. And talking about security with developers, with system architects, the typical answer that you should get on when you ask about security is either yes or yes very much, I care about it. Because that's the really essential bit about that.
Okay. Why do you believe RISC-V is a good candidate for intelligent edge computing specifically?
Mm-hmm. Several reasons. So first one, the openness. I'm not liable to anyone on paying royalties. If I'm using the ISA, I have the possibility of extending the ISA. So I can take a certain instruction set and then add my custom instructions to that. And with that, I can really build whatever I require. Also, additionally, looking in a combination with an FPGA, it even opens up an additional possibility. You can put the real hardware on something that is up to a certain degree fixed. So if you look at a PolarFire SoC, it has the ASIC part of the processing system, which is fixed. You can't change that, even though you might want to do it. But then you can add something kind of on the back of that into the FPGA fabric, getting the flexibility in. And the flexibility, the approach of doing that, it's, again, giving you the tools, giving you the freedom to innovate, having the right tools like the classical ones, HDL, Verilog, VHDL, building something on top of that that is just connected. But then also the possibility of just working on the code, C code that you have maybe from your normal development, and then empowering the software people to take a certain function and move it over into the FPGA fabric without really without being actively able to speak VHDL. That's another innovation driver here. And this coupled together with the large ecosystem that is present in the RISC-V area now, that's really something that makes it very, very suitable for those applications.
Okay. Well, I was wondering, how is Microchip supporting designers who are looking to design edge computing solutions with RISC-V?
Mm-hmm. So first of all, from the whole perspective, we have the tools available, which are kind of the essential bit. You need to have something to develop. So the tools are available. We have the boards available. We are also providing a lot of information on how to do it. Everything, or pretty much everything that you need to start with the development is public. It's on GitHub or it's on our website. So giving you that possibility. And then based on that architecture, also the ability to really create your applications on a very power efficient underlying hardware.
Okay, excellent. I was wondering maybe if we could now move into something where you could tell us about the PolarFire SoC FPGA family.
Mm-hmm. So the PolarFire SoC family in itself is an SoC, a processor, attached with some FPGA fabric. The processing system itself is based on RISC-V, quad-core application processor running at 600, 650 megahertz, depending on the speed grid, plus a fifth processor, which is doing the housekeeping, responsible for bringing the system up, keeping it running. And big benefit of the SoC system is also, it's not just a multi-core processor, but it's built to natively support asymmetric multiprocessing. What's the importance of that? If you have those multiple processors, you might want to use them in some different fashion. Maybe one just to use it as a Linux system, and some other one as a bare metal system, which needs to have real-time behavior. If you look at Linux, it can be sometimes a little bit cache greedy. So if it sees the memory, it just takes it. If you have the real-time system on the other side, and it requires a very tight deadline, a really very clear scheduling, and all of a sudden the interrupt service routine takes longer because it doesn't have the memory available, there goes your real-time performance. So this very clean-cut asymmetric multiprocessing with the possibility to firmly allocate cache, that's a very big benefit on those applications. So you can lock Linux into a certain area of the cache. It will only be able to work there, and the rest of the cache can be either available for the rest of the processors, for the FPGA fabric to interface there, and the same also applies to the other peripherals that we have as part of that. And I was talking about security before. Security is in our DNA, coming from our heritage in those applications, military-grade security. That's also something very, very important on the PolarFire. You start off with a very secure boot. You have the authentication possibilities. We have the secure memory on the chip, which is also especially protected. So possibilities to store keys, authentication certificates, all that part of that device. Okay. And then also, again, possibility to work in conjunction with the FPGA fabric.
Could you tell me about its power? I was told it had a lower power, and why would you say this is beneficial?
Mm-hmm. So low power, the typical claim that we make is around about 30 to 50% power saving compared to a competitive device. So the question is also very good. I get that quite a lot, especially if it's coming from an application that is cable powered. I have a cable here. I can bring in as much power as I need. Yes, I do believe that. You can get as much power in, but what does happen inside? This power is turned into heat. And the heat will not come out via the cable anymore. So the big topic is not the power consumption, but the heat generation. So if you look at the typical PCs, what's the most prominent thing? The fan, to get all the power out. And having a device which is running at half the power consumption, that's very likely also a device that might not need that fan. Might work with a passive heatsink if it's on the higher ambient temperatures, or completely without it. Looking at the demo boards that we are providing, none of our demo boards has any heatsink, not even the hose for attaching anything. We typically don't need that.
Okay.
So It's really this system cost that you can say, where you can really tremendously save on this lower power consumption. And it also goes with the larger footprint. So you don't need the fan. Automatically, system cost can be reduced. You don't need to spend the 10 euros for the fan. You'll save the space for the fan or the heatsink. You can get into a smaller form factor. You can achieve something additional. You can get smaller and get into some additional applications. So it's really a full chain that is following this lower power consumption.
Wow, fantastic.
And by the way, also from a quality perspective, if the devices don't get as hot, semiconductors age quicker if they are hotter. So also your fit rate improves.
Oh, wow, excellent, excellent. I was thinking maybe we could polish this conversation off by asking, where do you think RISC-V is headed?
Mm-hmm. As you could probably see, I'm pretty excited about RISC-V and its benefits, and also looking into the future. Our corporate vice president, Bruce Wire, already did a sneak peek in December on our next generation, PolarFire 2. And the benefits that it will bring is definitely tremendous. So it's pretty much doubling the capacities and the benefits that we bring to our clients. And for me, my personal perspective on it is more for less. More capabilities, more features for less effort, less power consumption. And if you were to ask me kind of bring it into one sentence, I would probably say something like magic ahead.
Well, thank you very much, Martin. It's been a very insightful conversation, and I hope you enjoyed the rest of the show.
Thank you, Kristian.